This is section 7.4, nth roots. Our objective today is I can find roots. Finding the square root of a number and squaring a number are inverse operations. To find the square root of a number a, you must find a number with the square of a. Similarly, the inverse of raising a number to the nth power is finding the nth root of a number. In example 1, we're finding roots by simplifying. In a, we have plus or minus the square root of 16y to the fourth. So we're looking for pairs of 2 that we can take out. So we know if we break 16 down, we can break 16 down into 4 and 4, and automatically that's a pair of 2's that can move to the outside. Breaking down our y to the fourth, we can break it down into y squared and y squared. And again, that's another pair, and so we know we can take that out. So our final answer is going to be plus or minus 4y squared. On example B, we're also looking for pairs we can take out. Now right now, we can see that this is raised to the 8th power, and we need to figure out how can I break that down so that I have something that's squared that I can take out. So I can just go ahead and rewrite this. And if I rewrite this, I can have negative square root of x squared minus 6 to the 4th power all squared. Because this 4 and this 2, if we multiply them back together, we'd have the 8. So now we have a squared, and we know that that's going to mean that there's 2 of these, so I can go ahead and take out an x squared minus 6 raised to the 4th power, and then I still have that negative that was out in front that I have to account for. So I'm going to have negative x squared minus 6 to the 4th power is my final answer. In example C, we have to notice that we're not taking the square root, but we're taking the 5th root. So when we have the 5th root of 243, a to the 20th power, b to the 25th power, we're looking for groups of 5 that we can take out. So we're going to break down the 243 just like we would normally break something down when we're looking for pairs, but now we're looking for groups of 5. So if we take 243 and divide by 3, we're going to get 3 and 81. 81 can break down to 9 and 9, and of course we know that 9 can break down to 3 and 3. And now we see we have 1, 2, 3, 4, 5 3's, which means I can take one of my 3's to the outside. So I'm going to go ahead and do that. So I'm going to have 3 5th root of a to the 20th, b to the 25th. But now I also want to go ahead and see if I can take any a's out and take any b's out. And since I have 20 a's, I know that I can take out a to the 4th, because that's going to be 5 times 4 would give me 20. And then with b to the 25th, I know that I would have 5 groups of 5, because 25 divided by 5 is 5. So I'm going to take out b to the 5th, so that my final answer is 3, a to the 4th, b to the 5th. In example D, we're going to do the same type of thing. Now first, you need to recognize that there's a negative in front of that 16. And remember, from our imaginary numbers, we can go ahead and just take an I out to get rid of that negative. So now we're going to have 16 x to the 4th, y to the 8th. And so now we've gotten rid of that negative. Now, because there was the negative 16, we know that there's not going to be any real roots, but we are going to have some imaginary roots. So now we want to keep working and see what we have pairs of. So we know the square root of 16, so we can break 16 down to 4 and 4, which means there's a pair of 4's that can come out. If we break down the x to the 4th, we want to see how many pairs are in 4, so 4 divided by 2 is going to give us 2. So we're going to take out an x squared. Now if you want to see this written out, I'm going to go ahead and write this out over here so you can see how this works. So if we write this out, we have x squared and x squared, and we have x, 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 and x if we break down the x squareds. And then here's our pairs, which would give us an x squared that we're going to take out. Same thing with the y. If we wrote it out, if we have 8 divided by the 2, because it's a square root, we're going to end up with y to the 4th. So our final answer here is going to be plus or minus 4i x squared y to the 4th. When you find an even root of an even power and the result is an odd power, you must use the absolute value of the result to ensure that the answer is non-negative. In example 2, we're going to simplify using absolute value. Now in this case, if we have the 4th root of y to the 4th, we're going to have to write this as the absolute value of y. Now the reason we have to do that is because these two guys were even, so we had a 4th root of y to the 4th. But here, our answer would have resulted in just y, which would be to the power of 1. So since that would be to a negative power, we have to take the absolute value of y to identify the principal root. Now looking at example B, we're going to do the same type of thing. If we were going to break this down, this is the 6th root of 64 times x squared minus 3 to the 18th power. And if we took the 6th root of this, we would break this down as 2 x squared minus 3 to the 3rd power. Now, since the index 6 is even, and the exponent 3 is odd, we must use absolute value signs around our x squared minus 3 to the 3rd power. In example 3, it's a real-world example, and we're talking about injury prevention. It says, well, first it's saying to refer to the beginning of the lesson. You guys don't see that, but we don't really need to do that for this anyway. It says, if c is equal to the 5th root of b squared, represents the number of collisions, and b represents the number of bicycle riders per intersection, estimate the number of collisions at an intersection that has 1,000 bicycle riders per week. Now, we have to understand that we want to find out how many collisions there are, so we're going to be solving for c. Now, they did give us 1,000 for bicycle riders, so we know in this case that b is going to be equal to 1,000. That's what they gave us. So now we want to take the equation they gave us. They gave us c is equal to the 5th root of b squared. So we want to go ahead and take the b that they gave us and plug that in. So we're going to have c equals the 5th root of 1,000 squared. Now, if we went ahead and solved this out, we could go ahead and do 1,000 squared, which would be a very, very big number, and take the 5th root. I'm just going to tell you folks, if you have something this giant, you want to go ahead and use your calculator for this. And if we use our calculator to approximate this, we're going to get approximately 15.85, which means that there's going to be about 16 collisions per week. So we'll write that as our final answer, about 16 collisions each week. In B, it says if the total number of collisions reported in 1 week is 21, estimate the number of bicycle riders that pass through the intersection. So this time, instead of giving us B, they're giving us C. So we're going to still use the formula that we had, but we're just going to plug in 21 for C. So we're going to have 21 equals the 5th root of B squared. And we need to go ahead and solve for that B value. So to get rid of the 5th root, we're going to raise each of these to the power of 5. Now 21 to the 5th power is going to give us a very large number. So we're going to have 4,084,101 equals B squared. And then to get rid of the squared, we're going to go ahead and take the square root of both sides, which is going to give us B equals 2021. And that's going to be the number of bicycle riders.